Assalamualaikum everyone. So today I'm going to teach you about chapter 5, which is network in graph theory. So my name is Izzah Syamini binti Ambok Mamak Fauzi. I'm from 4 Cambridge. So we're going to start our lesson. So let's go. Okay, we're going to start our lesson with introduction. So I'm going to show you the info zone. This is the symbol or the letter that we use in network in graph theory. So if you see this letter, so you know what does it mean. So G means graph, V means vertex or dot, so E means edge or line or arc. So D means degree and E is sum. So this is, you can look at the example of the vertex and the edges. So the dot is vertex, while the line, we call it as edges. So next. So now we're going to identify graphs. So look at these two pictures. What can you see in both pictures? What is the difference between both pictures? So the first picture we know as simple graph, while the second picture is a graph with multiple edges and loops. We don't call it as simple graph. So why does it call as a simple graph and another picture called multiple edges and loop? So I'm going to explain. Okay, first look at the second graph. Okay, this is a multiple edges and loops. So this is multiple edges and this is loops. Okay, multiple edges and loops, the difference is multiple edges has two edges, this one and this one, while loops there's only one edges, but it come back to the first point. So that is the difference between multiple edges and loops. So the simple graph means a graph has no loops and no multiple edges. So the sum of degrees of the graph is twice the number of edges. Okay, next we're going to solve the problem. Okay, look at the picture that I will show you. So how are we going to solve the problem? Okay, look at the picture. So as I told you just now, vertices is the dot, while the line we call edges. So now we're going to determine V and E. Okay, so what is V? V is vertices. So look at the picture. How many vertices are there? The vertices is a dot. So A, B, C, D, E, F, and G is the vertices. So write A, B, C, D, E, F, and G. Oh, you must put a curly bracket, not the simple bracket. So number of vertices is equal to 1, 2, 3, 4, 5, 6, 7. 7. So this is how you find the vertices. Next, edges. Equal to, edges means a line that connect two vertices. So look at the first one, A. A connected with B and G. So write like this. A connect B and then A to G. Next, B. B to C. We don't write B to A again because there's already A and B. So next one, C. C to D and then C to G. Okay, next one, D. D to F and then D to E. Okay, next we look at E. E to F and then F. F to G and then G. G, there's already C and G and A to G. So enough. So count how many edges are there. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there is 9 number of edges. So now, how are we going to find the sum of degree? So sum of degrees is twice number of edges. So number of edges is 9. So 2 multiplied by 9 equal to 18. So the sum of degrees for this graph is 18. So this is how you actually solve the problem. Okay, next one. This picture there is multiple edges and loop. So how are we going to find vertices, number of vertices, edges, number of edges, and sum of degree if there is multiple edges and loops? So I'm going to show you how. Okay, vertices, curly bracket. So there is P, Q, R, S, T, and U. So number of vertices is equal to 1, 2, 3, 4, 5, 6. 6. Okay, the edges. Okay, this is a bit different from the simple graph. Okay, look at the P. P to U. Okay, P to U. But this is multiple edges, so you write it twice. P to U. Because 1, 2. But you also can this way. Because you can write in any form, P to U or U to P maybe, but you have to write it twice because it is multiple edges. Okay, next one, P to Q. So we have Q to R, we have Q to U, then we have R to T, we have R to S, we have T, oh, sorry. We have, not T, we have RS and then S to T. And look at this is loops. So you have to write like this, S, S, because it come back to the first point. And then what else we have? We have T to U. I think that's enough. So count how many number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is 10 number of edges. What about the sum of degree? It's just same. You have to divide by 2. Number of edges divide by 2 equal to 2, 10, 20. So sum of degree for this graph is 20. So this is how you write or how you solve the problem with multiple edges and loops. The difference is only about the edges. Look at this. You have to write it twice for multiple edges, and for the loops you have to write like this, SS. Okay? Because it's connect with only one vertices. Okay, next we move to the next part. Okay, the next part is determine directed graph and undirected graph. So graph, there's a difference between directed graph and undirected graph. So look at the first picture and the second picture. It's the same picture, but for the first picture, there is an arrow. So when there is this arrow, it means it is a directed graph. And while the picture with no arrow, we call this undirected graph. So this is the difference between graph that have arrow and no arrows. We call it directed graph and undirected graph. Move on to the next slide. So now we're going to solve the problem, which is the vertices, edges with directed graph. It is different from undirected graph because there is an arrow. So I'm going to show you how to do the solution for directed graph. Okay, first, the vertices is still the same, P, Q, R, S, and T. So number of vertices is equal to 5. Okay, the difference is the edges. Okay, take a look at P. Okay, we start with P, okay? P to Q. So P to Q. You cannot write like Q to P. You have to follow the arrow where it goes from P to Q. What about the P and T? You cannot write P and T like you write in simple graph. You have to write T to P. You cannot write like P to T because you have to follow the arrow. So this is the difference for directed graph and undirected graph. Okay, next one, Q. Q to R. And then R to Q back. R to Q. And then we have S to Q. We have T to S. And then we have T to T. So number of edges, we do have 1, 2, 3, 4, 5, 6, 7. 7 number of edges. Okay? Okay, now I'm going to show you how to find the sum of degrees. The sum of degrees is a little bit different from the undirected graph. Okay, I'm going to erase this all because I need some space. Now I'm going to show you how to find sum of degree. Okay, for directed graph, you have to write like this. Degree in for P and degree out for P. You have to write for all vertices. So degree in means the edges that comes to P. So this is degree in for P. This is degree out for P. So how many a line that goes to P? 1. That degree out for P, also 1. So next, degree in for Q. Degree in 1, 2, and 3. Degree out for Q equal to 1. Okay, now degree in for R. 1 also. What about degree out for R? It's also 1. Okay, next. Degree in for S equal to 1. Degree out for S equal to 1 also. Okay, next one. Degree in for T. Okay, T, since the T is loop, so you have to count like this. Degree in. So degree in, this is you can be as 1 and also can be as 1. So degree in is for T is 1. What about degree out? 1, 2, and also 3. Degree out for T is equal to 3 because for loops you have to assume there is out and there is in for the degree, the edges. So that's why you have to count degree out for T and degree in for T and degree out for T 1 to 1. And then you have to plus the other degree out for T. So now we can find the sum of degree. Sum of degree for directed graph is equal to, you have to plus all the degree that we have found. Like 1 plus 1 plus 3 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 and plus 3. So that is equal to 14. So this is how you find the sum of degrees for directed graph. Now look at this slide, subgraph. Okay, what is subgraph? Okay, subgraph means part of graph or whole graph redrawn without changing the original position of vertices and edges. Okay, look at this example of question. Determine subgraph of this graph. Subgraph of this graph. Okay, this is the graph. This is the original graph. So this is the subgraph. So we have to determine which is the subgraph for this original graph. Okay, look at this first diagram. Okay, P to S. Okay, P to S, P to S. The line that connected with P to S, we call it E5. So this is also E5. So the first diagram is a subgraph. Okay, the second diagram, there is E2 for P and S. Okay, look at P and S. Is there any loops that is E2? No, the loops is supposed to be at Q. So this is not subgraph for the graph. Next, diagram 3. P to S connected with E3. Is it right? No, because the line that connected P and S is E5. So this is not a subgraph. Even though the loops on Q is E2, but this is wrong. Next one. Okay, the last one. E1. Okay, this is E1, right? And this is E5, correct? This is E4, correct? What about this E2? This is E3. This is E2 and this is E3. So this is not a subgraph for this original graph. So now you understand what is subgraph. Subgraph is just like a part or whole graph that we've drawn without changing the position of vertices and edges. Okay, next we move on to the next slide. Okay, now we're going to determine the tree graph. So what is tree graph? Okay, subgraph of the graph without without loops and multiple edges. So tree graph properties is without loops and without multiple edges. Okay. Next, all vertices are connected only with one edges. Okay. Next property, number of edges is equal to number of vertices minus 1. Okay, look at these two diagrams, diagram 1 and diagram 2. Okay, which one is a tree graph and which one is not a tree graph? Okay, look at the properties given. Without loops and without multiple edges. Okay, both diagram is without loops and multiple edges. Okay, next properties. All vertices are connected only with one edges. Okay, these vertices connected with one edges, 1, 1, 1. Okay, look at this. There is another edges that connected with one vertices. And then the next property is number of edges is equal to number of vertices minus 1. Okay, number of edges. Okay, number of edges is equal to vertices. How many vertices are there? 1, 2, 3, 4, 5. So 5 minus 1 is equal to 4. It's supposed to be, the edges supposed to be 4. So count how many edges are there. 1, 2, 3, 4. So this is a tree graph. What about this one? There is 5 vertices minus 1, supposed to be 4. Look, there is 1, 2, 3, 4 and 5. There is 5 edges. So the diagram 2 is not a tree graph. So that is meant by tree graph. So now we're going to solve information of network. So first of all, take a look at the diagram given, the table given. Okay. This is name of people and games. Okay, this name of people and the game. Game is the vertices. So the table below shows the data of 6 pupils and the games that they like. So they represent the information in the form of network. So how are we going to do the network? So first we draw. Okay, I'm going to make a vertices. I'm going to put this as chess. And then we have football. You have to make sure the vertices that you draw must be connected with the people. It can connect with other games that is for the people. Okay, this is football, and then we have over here is sepak takraw, and then over here we have netball. Then we have volleyball, and then we have badminton. Okay, so is there any game left? I think all the games already be plotted on the slide. Okay, now look at the first pupil, Edmund. He likes to play badminton and chess. So badminton and chess. So connect this badminton and chess. You have to write this is Edmund. Okay. And then Azwan. Azwan loves to play football and sepak takraw. So Azwan should be here. Azwan. Okay. And then Rajan. Rajan loves to play chess and football. So Rajan should be placed on there. Next, Aina loves to play chess and netball. So connect chess and netball, the ages. So this is Aina. Got Aina. And then we have Maria. Maria loves to play badminton and netball. So connect the ages of badminton and netball and write down Maria. And the last one is Jenny. Jenny loves to play netball and volleyball. So you have to connect netball and volleyball with the ages of Jenny. So this is how you connect or you solve a problem in the form of network. Okay, so network is really helpful for you to solve the problem. So you can connect the data given here in the form of network. Okay, take a look at next question. We're going to the solving problem part. Okay, look at the question. Okay, this is, we call it as a undirected weighted graph. Weighted graph. Because there is a distance, there is a number. It can be in hours, it can be in meter, it can be in kilogram, in mass. So now, look at the first question. Draw a directed graph to represent the shortest distance from A to F. From A to F. Okay. So, draw a directed graph. Okay. Now, look at the shortest time. The shortest distance. So, okay, look at A. Between 750 and 900, which one is the shortest one? And 650. Okay, so 900 is disqualified because it's the longest one between these three. And look at 750 and 650. Okay. First, I'm choosing 750 because if I'm choose 650, okay, should be like this and this. But if I'm choosing this 650, I have to go to this. It might be longer, so I'm choosing 750. So okay, next I'm choosing this one, and then I'm choosing between 800 and 500. I'm choosing 500, so 800 is disqualified. This is disqualified also. Okay, now ADC is supposed to path go to all vertices, all the vertices A, B, C, D. The edges, the path must go to all vertices. Okay, so next one is this. Okay, now look at 850 and 600. So which one is the shortest one? So the shortest one is 600. So we choose 600. Okay, now we just go to the E because there is no choice. Just go to B to E, and then you have to go to F, right? So just go to directly to F, because if you use this path, you go back to D, then you go back to F. So since we already moved to D, already go to vertices D, so we cannot choose vertices D again, because the condition must be all the paths are taken only once. Okay, so now let's draw the graph. So this is A, then we've got D, C, B, E, and F. Plot A, D, C, B, E, and F, like this. So this is for the question A. Okay, next, question B. It says solving problem. Based on your graph, calculate the shortest distance in time. So just calculate 750, I'm choosing the color, 750 plus 500 plus 600 plus 780 and 450. So the total is 3.08 kilometer. The question must be in kilometer, the answer. Okay, so that's how you solve the problem. We already come to an end of this video, so I just want to say thank you so much for you guys who watched this video, and I hope this video can help you guys to score in your exam, and you guys get new information, new knowledge on how to solve a problem in this topic. So I hope you guys get and pass the examination with flying colors and be successful in the future. So thank you so much.